let me record the session so it will be available for everyone. Bevo non-IT. Okay, no problem, Bevo. I'm going to take from very basics, okay, to a little bit in the deep. So not need to worry. Okay, again I'm going to provide all the learning materials and content. Okay, so even if you are not able to understand here, so no need to worry. Okay, you can go ahead again, watch the video. I'm going to give you so many videos, okay, around 30 videos. So you can go ahead and watch, okay, and learn from there. So no need to worry if something you're not able to understand. So it's completely fine. Okay, but just follow, pay your attention. I'll give my best to make everyone understand here. Yeah, IT professional, Bevo IT professional. Okay, so let's get started. So you can see my screen, right? Just to double make sure, if you see my screen, please type yes. So I will get started. Perfect, super. So everyone see my screen. So okay, let me start now. Okay. A little bit about myself. I see some of people, I know them personally. We are interacted somewhere. Okay, but if you don't know, I am Praveen Misra. I'm working as a AWS Finland lead architect for the Capgemini. I'm also AWS Map ambassador. I have so many certifications. I really don't care these certifications anymore, because once you have the experience, okay, and you know your steps, then certification don't really not matter. But one certification I see as very important is AWS Solution Architect Professional. Okay, so this is something good to have. And it's so something. If you have this certification, then it makes you know the steps. Okay, you know the architecture. You know the design. I'm also Google Cloud certified trainer, and that's pretty much about me. And that everything you can see on the LinkedIn if you are following me there. Okay. Okay, so directly I'm coming to the point. Okay, so before uh, we do anything, okay, we need AWS account. So AWS account is the prime uh, resource where we are going to design, architect, and implement our any AWS resources, right? Or design any high available architecture, correct? So we need a AWS account. Once we have AWS account, so in this account, to access this account, okay, if you are deploying your application, right, or customer applications, okay, you need a domain name, right? And that domain name could be somewhere, okay, it's not need to be in Amazon Web Services. Amazon Web Services has also a service called Route 53, where we can go and buy a domain name. Okay, and if you don't have domain name from there, you can buy from anywhere. Then you have to do some configuration in Route 53. Okay, then you're able to access your AWS resources. Okay, and then once you do that, then actual designing and architecting part starts. Okay, so first things first, we need to create a VPC. Okay, VPC stands for virtual private cloud. This is, we can say, this is your data center inside Amazon Web Services, where you have full control of this data center. Okay, so when we talk about the data center, right, so data center composed of IP addresses. Okay, it's composed of the network, right? And this network will have the IP addresses. You should have the control how people will access from the internet. Okay, how you access internet from your data center. You should have the route, right? So everything here you will get, and you will have complete control on your VPC. Okay, and I'm going to talk this one by one. Okay, what are these different component and how it works. So if it's clear so far, please type yes in the chat box. This is your webinar, so I'm only speaking, but you can chat here. Okay, so little bit more, make it interactive. Okay, also I know I'm not just talking. Okay, I see so many yes, thank you so much. Okay, so we have to create a VPC. Okay, to create VPC, we need only one thing that's called IP address range. Okay, and in terms of AWS, we call it CIDR. Okay, CIDR, CIDR range. And as an architect, as an engineer, we have to one thing make sure this IP address. Let me point out here. So this IP address, maybe I need to present it, then I can draw here. Okay, no, I'm trying to draw something here. Yeah, so this IP address need to be unique. Okay, why this need to be unique? It need to be unique uh, in terms of your IP address ranges. Let me rephrase it. So let's say if your customer, okay, having a network in the on-premises data center, okay, they have also a network in the other clouds, could be the Azure, could be the Google Cloud, okay. So this IP address should not be overlapping IP address. So what will happen when you have the overlapping IP address? Then you see, okay, resources will have same IP address cross environment, right? If it's in the Google Cloud and if you have the also same network in the AWS, it will have the same IP address, right? So it should not be, right? Because there could be chance these resources need to communicate to each other, correct? So that's why this IP address need to be unique, okay, across your network. Once we have that, then okay, so when we are creating this VPC, okay, I think we can skip that part. Okay, so once we have this VPC, okay, then this is our network, right? And here we will decide how this network going to connect to the internet and from the internet, right? Because at the end we are going to host and deploy our application, right? So this application need to be accessed from the internet, correct? So for that there is a service called internet gateway. So if we understand the name, right, internet gateway, so this is gateway from the internet. So how people will access and reach to your network, okay. So for that we need to create a internet gateway service, and this is very simple to create, okay. Once you create, then we need to attach to our VPC, okay. And one VPC could have one internet gateway. So again, just to repeat, internet gateway is high available AWS managed service that will give gateway from internet to your network, okay. So now we have our network and we know how people from outside reach to our network, right? Then we need to make our this network high available, correct? To make this network high available, we have concept of availability zone, okay. So before that, let me explain a term called AWS region, okay. So AWS region is a geographical locations of AWS data center, okay. So if you go in AWS account, then on the right corner you will see a list of the data centers, okay. So if you take example of the Mumbai region, it's mean in the Mumbai region AWS has 10-15 data center. So this number of data center is not disclosed, but you can imagine there should be at least 4 data center, okay. So you need to select you need to select a region to create your AWS resources, okay. So here once you select a region, right, so in this region there is also concept of availability zone, okay. This is availability zone. So availability zone is nothing but set of data center within the region, okay. So we can say Mumbai region has two set of data centers, and this set of data center is called availability zone. And best part of this availability zone is that This ability zones has independent network, internal network, cooling, electricities, okay, and this ability zones also far away, should be around 50 miles away. So if there is anything wrong happen in one ability zone, means one set of data center, it should not impact another set of data center. So this is purposefully designed. Okay, so why this is designed? Because when you design your architecture, then you can make your application and server available across two ability zones. So if your same application running in two ability zones, right, is mean in two data center, correct? So if XYZ region, if one region goes down, let's say there is no electricity, there is a power outage, there is a problem with the cooling, there is problem with maybe some disaster happen, right? So still your one region is, sorry, one ability zone is there, right, and your application will still running, right? So that is purpose of having multiple ability zones, and that's what we are going to take advantage of while designing our architecture. If this is clear so far, please type yes in the chat box. Thank you. I see so many yes. Okay. Thank you so much. So now let's go ahead. Okay. So what we'll be doing when we'll be designing our network, then we will select multiple ability zones to create a sub network. Okay. Now let's understand this part. And anyways, don't worry, I'm going to share these recordings, and also these things I explain in very details in another videos. I'm also going to share that as well. Okay, we have 129 people here as of now. I'm really happy to see that many numbers. Okay, so now here we have concept of called subnet. Okay, so let's try to understand this. Okay, so we have VPC. Okay, so VPC is nothing but our network, right? So in network we can create subnetwork. We can create subnetwork, and this subnetwork is called subnet. As name suggests, subnet, right? Subnet, subset of network. So this is subnet. Okay, so here you see I have created in my VPC, I have created two subnet. Okay, public subnet 1 and public subnet 2. Okay, and when we create this subnet, then we need to give also IP address. Okay, we also need to give IP address here as well. And one important thing we need to remember, this IP address should be subset of this IP address, VPC IP address. Okay, this is mandatory because this is very common, right? When we are creating sub network, right, it should be subset of this IP address, correct? So we will use, you can give the name and that's all. Okay, so here we can create sub network. Now important point, right? Now here we are talking about the high availability. So to make sure our network is high available, right? So this is basic building block for our architecture. If our network is not high available, right, then how we can make our application high available? Because our application will be in those network, correct? So that's why we need to design our network high available. So for that we are creating two subnets, public subnet 1 and public subnet 2, and we are keeping this public subnet across two availability zones, right? So you see same public subnet have across two availability zones, right? It means this is high available, right? We have two same network in two availability zones, right? So this is high available. Okay, further we can also create private subnet. Okay, now what is difference between public subnet and private subnet? Okay, so as you see here, okay, and also when you create, there's no difference the way we create subnets. Okay, while creating subnets, we have to give the name, and you can give the name public subnet or private subnet. But as per this design, okay, what I'm suggesting and what I'm designing, I'm creating two public subnet, okay, need to delete it. So I'm creating two public subnets, okay, and I'm creating two private subnet. I got answer from the Rasmi. Okay, public subnet is connected to the internet. Correct. But when we create these subnets, so there's nothing like this, right? Just we create and give IP address range and name it. Correct? And that's all. So whether you name it public subnet and private subnet, there's no difference. But difference is how we are going to implement it, right? That's where a route table come in picture. I'm coming there. Okay, so here you see, right, we have two public subnet and two private subnets. So we created four subnet, right, and we name it public and private across two ability zones. I hope this is clear so far. There is also people prefer creating data subnet separately. Okay, here you see. So what actually we do, right? So when we design our solution, okay, something we put in the public subnet, something we put in the private subnet, and something we put in our DB subnet. Actually, this should be the DB subnet. Okay, so DB subnet 1 and DB subnet 2. So what ideally we'll do, we'll keeping web servers or maybe load balancer in the public subnets. Okay, app server in the private subnet, then database in the database subnets. Okay, and these all are private. Okay, now very important point, we need to understand, okay, how this is public subnet and how these are private subnets. Okay, and this is something what we do in the route table. Okay, so okay, so far it's clear, right? So we have created VPC, we have created subnets, okay, and we name it public subnet and private subnet, right? Then next what we do, we create a service inside AWS called route. Okay, once we create a route, okay, we create a route table. Okay, in a route table we define route, and this route is very important. Okay, in route we decide and we define how traffic will flow inside the network and also outside the network. Let me repeat this. Okay, so as of now everything was as it is and the same. There is no difference between public subnet and private subnet. So difference comes the way we decide how traffic will flow inside these public subnets and private subnet. And for that we create a route table. Okay, and the route table associate with the subnets, and in this route table we define, okay, routes, and these routes decides how traffic will flow. So now let's understand this. So here if you see, this VPC has IP address 10.0.0.0/16, means this is IP range for our VPC, correct? So what we are saying here, destination. Okay, so in route table we have two concepts. Okay, one is destination and one is target. Okay, so we are saying if destination is VPC CIDR range, if destination is VPC CIDR range, then traffic will be local. So traffic will flow inside our VPC. If someone is trying to reach any IP address within our this IP address, if anyone trying to reach within this IP address, okay, so this traffic will be local. So what route table will say, hey, this IP must be inside this network. Okay, so it won't look outside. Whereas if you see the another entry here, we have 0.0.0/0. Okay, and there we are saying IGWID. Okay, so if other than this traffic, okay, any traffic, okay, and this is something called any traffic, okay, so any traffic other than this traffic will going where? Is going to the internet gateway. We are telling explicitly other than this traffic will go to the internet gateway, IGW. So this is ID of this internet gateway. So we are saying, hey, if you need other than this network, then you can go to the internet gateway. So any traffic other than local, it will go to internet gateway, and from here it will go to outside. Okay, if it's clear, please type yes in the chat box. This is very, very important. Super, I see so many yes. Thank you so much. Okay, now let's understand one very important concept here. Okay, now we know how to reach to internet and how reach from internet, right? And for that we have created a route table, and we attach this route table with our public subnet, correct? Now we have also four other subnets that's called private subnet, right? So there is one very important things we know. Okay, while creating these subnets, we why we given this public subnet, why private subnet? Because there was some reason, right? When we given name public subnet, it means this will connect from the internet, right? When we call it private subnet, it's mean we want to make it private. We don't want it to open for anyone else, right? That's why we called it private. Now how do we make it private? We make it private with our route table. Okay, and in route table the way we define the route. So if you understand so far, so here we make these subnets public with this route table, right? And this route table we attach to our these subnets, right? And we said any traffic, okay, can connect to the internet gateway, right? It's mean anyone can reach to this public subnets, and also any services here in this subnets can go outside. So that's why now this is our public subnets, right? Now we don't want this network to make it public, okay, so we are not going to attach this internet gateway. If you don't attach internet gateway, means your subnet is private. It's very simple. If you're not going to attach internet gateway to your other subnets, so it will be private. So this is private now, okay, that's for sure. Okay, so there is question from Srinivas. Is there rules for the traffic going outside of the VPC? Yes, we have the rules. Okay, that's what we are going to talk here now. Okay, now here if you see so far, okay, for the public subnet, people can reach from outside to internet, and also service from here can reach outside of the internet. Sorry, outside of the VPC. Okay, but here we want anyone should not reach our private subnets. That's why we called it private subnet. That's very clear, right? But there could be the reason, there could be the some cases you need to access internet from these subnets, because let's say if you have the application, right, you need to download source code of your application there, correct? You need to, let's say if you need to connect to the external database that's somewhere on the internet, right? So you need to connect these subnets to the internet, right? So we can do that with AWS service called NAT gateway. Okay, so we have service called NAT gateway. So what we will do, we will create a NAT gateway service inside our public subnet. Okay, and we will configure and create another route table for our private subnets. Okay, and here we will define internet traffic. Okay, internet traffic will go to the NAT gateway. Okay, so here we are saying other than any internal network, okay, all network will go to the NAT gateway, and as NAT gateway is in the public subnet, right? So it can directly reach to the internet, right? That's we understood, okay? So this is the way we define how traffic will flow from our private subnet. If this is clear, please type yes in the chat box, then we will go to the next. This is very, very important concept. Super. I see so many yes. Thank you so much. Okay, so here what we have done so far, we have designed high available network, right? So once our network is ready, now we can create resources inside this network, correct? So now we'll go to the next step. Okay, the only difference between, yes, Srinivas, you were right. So Srinivas is asking, okay, the only difference between private and public subnet is no incoming traffic to the private subnet. Yes, this is right. Very good questions. I think it's also make concept a little bit clear to the other people as well. Okay. Now let's go to how do we create the resources. Okay. So let me go to the other slide. Okay. Okay. Now there is some questions coming. What I would say, please park this question for the last, okay? Otherwise what will happen if I keep answering these questions, okay, then we won't complete this session, right? So in last I will answer all these questions. Okay, so this is something we have done so far, correct? So we have designed our network, okay, and when we say DB subnet, right, and the private subnet, this is nothing same, okay? That's why I have combined these subnets, okay? Now what we will be doing, we will be creating a resources inside our subnet, okay? So here what we'll do, okay, we can go and create a EC2 instance, okay? If you don't know EC2 instance, EC2 instance is AWS compute service, okay? So this is nothing but similar to our laptop, okay, or our laptop, our PC. So it has a memory, RAM, processor, okay? So if you want to run any application in AWS, so you need it. There is other way of also running your application, but here we are talking about the EC2 instance. So you can go and create a machine, okay? This service called Amazon EC2, okay, Elastic Cloud Compute. Simple term, this is nothing but a computer. It has memory, RAM and the processor, and also come with some storage like our laptop. And we can go and run our application there. So if we look at the architecture, right, here we have created a EC2 instance, okay, to run. Let's say we have the blog, okay, and we want to run this blog. So what we do, we go and create a EC2 instance in our one of the subnet, right? So when you create a subnet, sorry, when you create a EC2 instance, so you see we have created only one EC2 instance, right? So this is not high available, right? Because this is only in one subnet, correct? Okay, we are coming on the high available later, but now let's understand, okay, this EC2 instance need to be accessed from the internet, correct? Because here we have the our blog. So this is in the private subnet because we don't want anyone access our EC2 instance or our application, right? So how do we make this available to the public, okay, accessible from the internet? For that, what we do, we go and create a service called load balancer, okay? So load balancer is again AWS service, okay? It's high available by default. It comes in the three flavor, okay? Classic load balancer, application load balancer, and network load balancer. So here I'm saying we can go and create a application load balancer, okay? As we want our application to be accessed, a blog to be accessed from the internet, so we put our load balancer in public subnet. one important things. Okay, this load balancer could be even public or private as well. So as we understood, we want our application to be accessed from the internet. That's why we put in the public subnets, means this is public load balancer. Perfect. Now what we do from here, okay, is public, right? So if you have the domain name, then you can configure domain name with the load balancer and it will be able to access our application, correct? So now this is pretty much clear, but problem is that here, okay, this load balancer is, sorry, this application and EC2 instance is not high available, right? To make this high available, what we do, we use a AWS service called auto scaling. Okay, so AWS auto scaling is the AWS service that automatically scale our EC2 instances, okay, our compute service, okay, based on some configuration. As name suggests, this is auto scale and scale down our EC2 instances. So once we configure, so what it will do, it will able to scale this our EC2 instances. Okay, we configure auto scaling with this our EC2 instance and it will automatically scale if needed. Okay, we also scale down our EC2 instances when needed. Okay, so we are going to use a service called auto scaling. So auto scaling has three configuration. Okay, one called minimum size. Okay, so minimum size, the number of EC2 instance you want to run inside your auto scaling. This is minimum number of instances you want to run inside your auto scaling group. So here I have given one. Another concept is configuration is called desired capacity. So it's number of instance that always will be running inside your auto scaling group. Okay, now third is maximum size. Okay, so maximum number of instances can run in your auto scaling group. Now let me explain it in little bit detail. Okay, so if you see here what I have done, I have created this three configuration. For the minimum size I put it 1. For the desired capacity I put it configuration 2, and for maximum size I put it this 4, right? It's mean auto scaling always makes sure we have 2 running EC2 instances. So this is the desired capacity, desired number of instances. As name suggests, so I want there should be always 2 EC2 instances running in my auto scaling group. Okay, now you say why maximum, why minimum? Okay, so let's say on the weekend, okay, I know there is a more traffic on my blog or my application. So I want when there is a more traffic, then this number of instances should increase, right? Because if not increase, then there will be the low performance on my EC2 instance, correct? On my application, there will be slowness. So I want my application instance need to be scaled. Okay, so that's why we given number maximum size. Okay, so again to increase this number we need to do some configuration. I'm talking shortly. Okay, so based on that configuration it will increase this number of instances. Okay, how many it will increase? It will increase maximum 4. It will not increase more than 4. Okay, because let's say if someone is hijacked, right, our network, and you just bombarded with so many traffic, what will happen? It will go and increase, it will create 100 EC2 instances, right? Then we will be built unnecessarily. Okay, and as application owner we should know, okay, what is expected traffic, right? So based on that, we are doing this configuration, and we can change this any point of time. Okay, so this is something cap we know, and based on that we have configured. Okay, now there will be also chance, right, when there is no traffic. Okay, let's say could be in the night time, correct? Night time people not be using your blog or the application, right? So we want this should be scaled down. Okay, so again we do some configuration, and based on that configuration it will scale down. So what if it will do, it will make sure, means it will scale down to minimum 1. Okay, it won't become 0. So we are setting up cap. Okay, what is the maximum number of instances, what is the minimum number of instances? Okay, I hope this is clear. If yes, please type yes in the chat box. Okay, super. This one important question, so I would like to answer these questions, is coming from the Chetan, because this is quite related and interesting questions. Okay, so Chetan is asking, there's so many yes. I need to scroll on the chat. Okay, yeah, can I keep minimum and desired capacity same? Yes, Chetan, we can make a desired and minimum capacity same. Okay, there's no problem. Good question. Okay, now once we do that, so how it happens? Okay, so what we do, okay, here in our private subnets we go and create a auto scaling group. Okay, and the auto scaling group, what will happen, a EC2 instances will come up. So in auto scaling group there is configuration where we can say, okay, when you launch EC2 instances, then you use this to ability zone. Okay, we can configure, okay, where this auto scaling will go and launch EC2 instances. Okay, so we'll say, hey, when you launch EC2 instances, then please use my these two ability zones. And these two ability zones, I have private subnet 1 and private subnet 2. So what auto scaling will do, it will launch our EC2 instances across these two ability zone. Okay, and these two subnets. So now our EC2 instance is high available. I hope this is clear. Okay, now you must be thinking, right, in this architecture we make two public subnet, two private subnets, right? Now we have our EC2 instance is high available across two availability zones. What about this load balancer, right? So load balancer is AWS managed service, and this is high available by default. So when we create a load balancer, to AWS expand this load balancer across our public subnets. Okay, and it's create multiple load balancer, but this is something we cannot see. When you go in the load balancer console, you cannot see it. Okay, you will see only load balancer. Okay, because load balancer has the public DNS, right? So we will see only one load balancer, but underneath there are multiple load balancer are running. Okay, and based on your traffic, and this is high scalable, seamless, high scalable, and you don't have to do anything there. I hope this is clear. There is question from the Lakshita. Okay, sir, minimum size, maximum size did not understood. Okay, I will. Okay, I think it's very important and related to this. Let me explain this quickly. Just give me a moment. Okay, so let's understand. Okay, let's say you have the blog. Okay, blog, you want to run two EC2 instance all the time to make sure it will serve the general traffic of your application. So you have the blog, okay, and you know if you will be running two EC2 instance, then it will serve the general traffic, okay, all the time, most of the time. Okay, now on the Sunday, on Saturday, because of the weekend, there will be more traffic. Okay, then there could be this traffic could be double of your normal traffic on the normal day traffic. Okay, so if you can add to more EC2 instances, then it will balance the performance. Okay, so what you can do for that, you can go and in auto scaling you can configure this maximum size. Okay, so on the high traffic day, what auto scaling will do, it will scale your number of instances. Okay, so how many it will scale, what is the maximum number? So you are saying, hey, you can only create 2 additional EC2 instances. You cannot create 10 instances. You are setting up upper limit to auto scaling group. You can only create, you can scale, but only scale up to 4 EC2 instances. You cannot scale more than 4. Okay, so this is upper limit of your scaling. On the reverse, okay, you also know, okay, in the night time there is no traffic, so you don't want to pay to the AWS for the services. Okay, then you also configure in auto scaling, okay, hey, if there is no traffic, scale it down to 1. Okay, so it will scale down to 1, right? So you want your application should be running all the time, correct? If you scale down to 0, it means if someone is hitting your domain name, then they will get 404 or 502 server not found error, correct? So that's why you will set minimum number 1, and this could be any number. Okay, maximum you can set 10, minimum you can set 1. Okay, you can set 0 as well, but this is meaningless, right? Because when some people are coming in the night and they will access it, they will get 504 server not found, right? I hope it's clear now. See my screen. Okay, so how do we scale this, right? And for that we need to use some AWS services. Okay, so this another AWS service called CloudWatch. Okay, so CloudWatch is AWS monitoring service. So what CloudWatch do, it's monitor our EC2 instances inside our auto scaling. Okay, so based on this monitoring, what it do, it's raise some alarm. Okay, so when we monitor, so we can monitor different parameters. It could be, let's say, our EC2 instance memory. If we see memory is crossing certain limits, then it should raise the alarm. If CPU is going below or going from the certain level, then it will raise the alarm. Okay, and it could be based on different metrics. So what will happen when you create EC2 and there is one tab called the monitoring? When you go in the monitoring, then you can see the different matrices. Okay, and on those metrics you can raise the alarm. Okay, so CloudWatch will have the alarm. Okay, once you see the alarm, right, and this based on this alarm, what you can do, you scale in or scale out your EC2 instances. Okay, now let me repeat it. Okay, so far we have auto scaling, right? What we can do on top of that, we can monitor our auto scaling EC2 instances with help of CloudWatch. Okay, so when it will monitor some matrices of our EC2 instances. Okay, and if it finds, based on our configuration, if CPU go beyond 80%, then it will raise the alarm. If memories goes below 10%, it will raise the alarm. Okay, so based on this alarm, we will add number of instances or will remove number of instances. Yes, so it's monitor over uses. Exactly, so it's monitor over uses, also under uses. Okay, so now see the flow, how it works. Okay, so basically CloudWatch is monitoring. Okay, it will monitor, then it will erase the alarm. Okay, once it erase the alarm, then alarm, okay, so based on the alarm we'll have the scale in and scale out. Okay, and then it will go and add number of instances to our EC2 instance. Okay, I hope it's clear. So based on alarm, okay, our auto scaling will add and remove EC2 instances. Okay, now we are making our EC2 instances high available based on with help of auto scaling and load balancer. One important concept I want to cover here, okay, because we have only 10 minutes remaining. Okay, I don't want to take you more time. Okay. Okay, so here we see, right? So now, as of now, what we are doing, we are monitoring our EC2 instances under auto scaling group, and then we will scale in, scale out, right? And one very important concept is here, okay, to add these EC2 instances, okay, we also need to create a AWS resource called launch configuration, okay, or launch template. So launch configuration and launch template is configuration of EC2 instances. Okay, now let's understand this, right? When we are launching a EC2 instance, right, so EC2 instance has some configuration, correct? Whether you create a EC2 instance from AWS console or AWS CLI or SDK, right? When we create EC2 instance, then we give some configuration, correct? And this configuration we can also put it in one place, okay, and that's called launch configuration and launch template. So earlier it was called launch configuration, now we are calling it as a launch template. Okay, so auto scaling will always use launch configuration and launch template to launch a EC2 instances. Okay, and top of that, coming to the backend, right, we can create a RDS instance, okay, or even you can create EC2 instance, then you can install the your database there, but that's not recommended. Okay, what we can do, we can go and use Amazon RDS. So Amazon RDS is again AWS service which support different database engine like MySQL, Postgres, Oracle, MS SQL. So based on your needs, you can go and create Amazon RDS. Okay, and then of course this is a database, right? And then it will connect to your EC2 instances. You can also make your RDS instance high available. Okay, so there is concept in Amazon RDS, okay, making your database high available. And this is very simple one tick button. Okay, when you create your RDS instance, then there is a button you can tick it. Okay, and it's create a your database high available in another availability zone. Okay, so this will be high available. Okay, so this was all I wanted to cover in this webinar. Okay, so our high available architecture starts from designing our network, configuring our servers, then configuring our backend. Okay, and same time we need to automate this server creation. Now this was all about theory, right? Now you must be thinking, right, how you go and implement it. So for that you need to go on my YouTube channel, and on my YouTube channel, okay, there is playlist called AWS hands-on. If you click here, I have around 30 videos. Okay, and whatever I have explained you so far, okay, this is covered till from second, okay, from second video to video 10. You see here, auto scaling in and out. Okay, in and out. So everything what I have explained to you here, okay, in 1 hour, I have everything recorded in very detail. Okay, so you can go ahead and find everything here. Okay, and here what I have done, I have also automated everything. Okay, so this is best place for you to go and look those videos, understand and practice it. And top of that, I have also so many videos on hands-on creating different AWS resources. Okay, so I will recommend go ahead and give a try there. Okay, now I am open to the questions. We still I see 128 people, so 100 plus number is really good number for me. So that was also one of the reason I don't want to uh, uh, don't drop this webinar. Okay, I see so many uh, people with a really good uh, intention to learn. Okay, join, spend your uh, personal weekend time, family time to learn something. Okay, so I don't want it to disappoint. Okay, that's why I'm here. Okay, top non-tech session. Thank you so much, Srinivas. Thank you so much. Could you please, okay, I've done. Could you please move than one standby DB configuration in RDS? Can we have more than one standby DB configuration in RDS? Oh, Prana, Parna. Okay, so I don't understand what you mean. Okay, so why we need more than one instance, a standby instance, right? So we have, just a second. I see, oh, so many feedbacks. Thank you so much, guys. Thank you so much. Okay, this is something also helped me, right, doing this kind of sessions. Okay, thank you so much. Okay, so question is, okay, so when we make our RDS instance high available, right, so only purpose of making it high available, right? So if you are running your database in one subnet, right, and another subnet, if you make it high available, right, so if one goes down, so your database DNS will switch to this database, right? If let's say this one will go down, again it's working here, right? Then we really don't need to a standby. Okay, but there is one concept. Okay, you can make your database not high available, is more performance for the read kind of query. Okay, now let's understand this. So let's say your master database, okay, will have access of read and write. So on application request is coming, so it will also for read traffic, also for write traffic. So highly if your application is highly read applications, okay, means this a lot of read query is coming, then what you can do, you can create a read replica. So this is new concept, not new concept, this is a different concept than high available. You can create multiple read replica, okay, and all read traffic you can send to your read replica instance. Okay, so this way you can make your database more performant. Okay, but high availability you really don't need it. But again, I'm taking it a little bit further. If your intention is from the disaster perspective, if you see this whole design what we have done, right, this was in one region, correct? In one region multiple ability zones. If this whole region goes down, then what will happen? So if this is your question, then we have option. Okay, we can create same network in another region. Okay, and that is called, okay, warm warm DR. These three types of DR. Okay, we can design it. Okay, so we can create same network in another ability zones. Okay, sorry, another regions. Okay, to make sure if one region goes down, another region is available. And for that, again, you need to replicate everything. Sorry, you need to replicate every data what you have in primary region to secondary region, right? That's where you can use database replication. Okay, now Redis starts supporting database replication. Then you can replicate your data from one region to another region. Okay, same you can do for your EC2 instance backup as well. Okay, you can take snapshots of your EC2 instance and you can share to other region for the backup purpose. Okay, I hope that clear your concept. Vijay saying thank you so much for your session. It was really good. Thank you so much, Vijay. Thank you, thank you, thank you, Sadika. Thank you. So many. Thank you, thank you so much. Thank you so much. Okay. I see if you can take any other questions. Okay. I think okay. Load balancer will distribute the traffic evenly. If load balancer find the instance unhealthy, it will stop. Yes, Rasmi, you are right. Okay. So if any EC2 instance is not healthy, then it will stop sending traffic to that unhealthy EC2 instance. It will only send traffic to the healthy EC2 instance. It monitor our users. Exactly, is monitor. Any other questions? Please let me know. What you mean AMI? Okay, AMI is okay. AMI stands for Amazon Machine Image. Okay, so what will happen when we create a EC2 instance, right? So we configure everything there, correct? So we configured our application configuration, database configuration, some additional softwares, right? So once you do everything, then what we can do, we can create a image of this EC2 instance. Okay, so okay, so okay, once you've done, right, then you don't want to do these things again and again, correct? So for that we create an image of our EC2 instance, okay, as a backup. So next time what we'll do, you use this image and create new EC2 instance and everything will be there. Okay, so it's called Amazon Machine Image. Okay, so you can create image of your machine. Okay, thank you so much. I see so many thank you. Okay, Bevo, thank you, you understood it. Just I'm trying to find some questions. If I can answer, earlier I was not able to answer it. Okay, one question from Vijay here. How load balancer and auto scaling is interlinked? Very good questions. Okay, so in a load balancer, okay, we will say, okay, so auto scaling for scaling number of instances, correct? Auto scaling will create more number of instances. It's also reduce your number of instances, right? Then auto scaling, sorry, so your load balancer need to know, right, how many instances are there and where these instances are, right? So that's where we need to inform load balancer, okay, this is my auto scaling, and any instances in auto scaling, okay, you need to distribute the traffic. Okay, so that's where auto scaling and load balancer are interlinked. And load balancer checks is your auto scaling instances are healthy or unhealthy. If only healthy, it will send the traffic. It's not healthy, it won't send the traffic. I think I see so many yes, so many things. Okay, if someone asked any question earlier, okay, I'm not able to find it. So that's why I was saying if you have any questions, ask in the last where I can find, where I can answer it. So I see again so many thanks, okay, and thank you so much. I think we are done. Okay, still I see 121 people here. Okay, so thank you so much for making time from your family life, personal life, for coming and learnings. I also see so many feedbacks. So thank you so much for your feedbacks. Okay, and I'm going to make sure I will take your all recommendation for the next sessions. Okay, and I will create and I will plan my next webinar like this. Okay. So that's all. Thanks a lot. I wish you all a great weekend. Spend time with your family, with your loved one. Get energized so you can start do good work in the next week. Thank you. Thank you so much. Thank you. Thank you. Thank you. Thank you. Thank you so much. Thank you. Thank you so much. Thank you so much. Thank you so much.